watching the Weiss channel. So, today we are going to talk about exponential equations. What? Don't be afraid of the term, it's just a word. Alright? For example, 8 equals 2 to the what power? Well, 2 times 2 is 4. 4 times 2 is 8, right? So 2 times 2 times 2 is 8. So 2 to the third power is 8. In other words, 8 equals 2 to the third power. So, question mark, equals 3, right? All right. 81 equals 3 to the what power? 3 times 3 is 9, times 3 is 27, times 3 is 81. Oh! 4, right? 3 to the fourth power. 64 equals 4 to the what power? 4 times 4 is 16, times 4 is 64. To the third power. Right? Question mark equals 3. Okay? 125 equals 5 to the what power? 5 times 5 is 25, times 5 is 125. Oh, to the third power. Question mark equals 3. All right? Now, don't let this confuse you. All right? This is actually very easy. In order to solve for x, if I say 5 to the x power equals 5 to the third power, if these bases are the same, 5 and 5, then the exponents have to be equal. Meaning, if this is 5 and this is 5, then x has to equal 3. Done. X equals 3. And that's it. Okay. Here, 7 to the x equals 7 to the 31st power. X equals 31. Done. Okay. Now, here's where it gets interesting and fun. All right? Do you see how the bases are different? Here the bases were the same, here the bases were the same, here the bases are different. So, what do you have to do? You have to make the bases the same. Okay? Meaning, 8 is the same as 2 to the what power? 8 is 2 to the... Who can tell me?
Wait,
8 is 2 to the what power? 8 is 2 to the what power? 2 to the third power. Does it make sense then that 2 to the third power equals 2 to the 2x minus 5? Does that make sense?
Oh yeah,
because I'm saying instead of 8, I'm writing 2 to the third. Why did I write 2 to the third? Because I want to make the bases the same. Here the bases are not the same. Here they are. This was easy because the bases were the same. This was easy because the bases were the same. But here the bases are not the same, so I want to make the bases the same. Okay? So 8 is the same as 2 to the third power. Okay, so now all I need to say is 3 equals 2x minus 5. No, because I'm solving for x now. What do I do? Plus 5. So I get 8 equals 2x, divide by 2. 4. That's it.
So we're going to see him cancel the 2 though?
Uh-huh. Okay? All right. Okay. Next. 81 equals 3 to the what power? That's right. So 81 equals 3 to the what power? 4, right? So 3 to the fourth power equals 3 to the 3x minus 11. So now that the bases are the same, I can now say 4 equals 3x minus 11, right? Plus 11 on both sides, right? 4 plus 11 is 15. Divide by 3. Not 3x, just 3. 5. Easy, right? It is. Okay? 64 is 4 to the what power? 3. So 4 to the third power equals 4 to the 5x minus 7. Don't pause. Mr. Alvarez. Okay. Okay. Who? I don't have him till next period. Okay. All right. So 3 equals 5x minus 7. Add 7. 10 equals 5x. Divide 5. Nope. You're subtracting instead of dividing. 2, right? Okay? All right. 3, right? 125 is 5 to the third power. So 3 bases are the same. 3 equals 4x minus 9. Plus 9 on both sides. Thank you, Brody. Divide 4. 3. Brody, you're on fire. Okay. All right. Now, here's where it gets extra interesting. All right. So 27 isn't 9 to a power. All right. So, but this is 3 to a power, and this is 3 to a power. So I'm going to make this 3 squared. Not 9 is 3 to the second power, right? But now I'm going to put the x plus 3. Don't lose that. I'm going to put it in parentheses. 27 is 3 to the third power times the x. Okay? So now we have 2 times the quantity x plus 3 equals 3 times x. Do you see what I did? We're going to distribute. 2x plus 6 equals 3x. I'm not going to cancel out the 6. I'm going to take away 2x from both sides. Okay? And I get 1x, right? Which means 6 equals x. That's it. Easy, man. All right. Here, sorry, those of you who came late, I didn't get you a worksheet yet. I will do that in just a minute. Here are the first 4 problems on your worksheet. All right. 6 to the 2r equals 6 to the 2. All right. This one, the bases are already the same. So 2r equals 2. Divide by 2.
See, you do it too.
What?
You put x instead of r.
Oh,
See?
you're right.
You're so used to writing
I'm
x.
so right
See?
used to writing x. I wrote x. Very good. It does not. I will not mark that wrong. I make that mistake. Wait, I don't make any mistake. What am I talking about? Anyway. All right. What about this? Wait a minute. 5 to the 3 minus x equals 1? Whew. Did you know that anything to the 0 power equals 1? That's right. Yes. Anything to the 0 power equals 1. 7 to the 0 power equals 1. 3 to the 0 power equals 1. Negative 35 in parentheses to the 0 power equals 1. So, would it make sense to say that 5 to the 3 minus x equals 5 to the 0? You understand why I use 5 to the 0? Because that's this base, so I'll use it as this one. Anything to the 0 power equals 1. So, 3 minus x equals 0. I'm going to add x to both sides. I'm going to get x equals 3. Okay. Over here, 3 to the v minus 3 equals 3 to the what? Third. Very good. So v minus 3 equals 3. Add 3 to both sides. 6. Okay. Over here, there's two ways you could do it. You could use 4 to the power or 2 to the power, either one. I'm going to use 4. 64 is 4 to the what power? 4 to the third. Now you got to bring down the negative 3x minus 2. 16 equals 4 to the second times negative 3x. Now that I have the bases the same, I bring down the exponents. 3 times negative 3x minus 2 equals 2 times negative 3x. Now, what I did not do at this point, I didn't go ahead and distribute yet. You could have, you can skip this step if you want. I'm going to distribute now. 3 times negative 3 is negative 9x. 3 times negative 2 is negative 6. 2 times negative 3x is negative 6x. I'm going to add 9x to both sides. I get negative 6 equals 3x. Divide 3. X equals negative 2. You've been watching the Weiss channel. Da 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 da.